In this video I'm gonna uh, find the electrical dual networks of a given electrical network, and I'm gonna show you how it's done. It's very easy and it's very kind of intuitive. So let's get started. This is the most fundamental circuit. So say a circuit which has series, say a circuit which has series resistance and inductance. So RL circuit with a voltage source, say a voltage source, this is a voltage source. So what is the dual of this network? So if I take the dual of this network, so the dual of R is G, and so resistance, dual of resistance is conductance, and dual of inductance is capacitance. So its dual will be, a current source with conductance. So this is not typical resistance as one might think. This is field conductance and capacitance parallel. So G isn't 1 by R, okay, rather G is electromagnetic dual of R, is what I'm saying. So R is V by I and G is phi D by phi B. So the two are different. Just like L is phi B by I, C is phi D by V. So, or charge Q by V. So L and C aren't inverse, but they are electromagnetic duals. So these are very important distinctions I am making. So this is C. So the parallel, the dual electromagnetic dual circuit. So this is I current. So current direction is from like this. So this is the dual network. So for the series RL circuit, its dual is parallel GC circuit. So this is a series circuit with resistance R1, R2 Rn to Rn. So, and this is a voltage source. So what is the uh, electromagnetic dual circuit of this? So it is very simple. The electromagnetic dual circuit of this is a current source, then conductance, it's the field conductance. So G1, G2 to Gn. So this is the electromagnetic dual circuit of the series resistive circuit, which is the conductive circuit. And G is basically the, what does it says, what do they say, the dielectric loss through the insulating path. And R is mostly known, and dominating. R is the loss in conducting path. Feature between R and G duality. So R is the loss through conductive path, loss through conductive path, and G is loss through insulating insulated path. So this is the main distinction between R and G. Delta connection. Say we have delta connection of inductors. So so say this is a delta connection of an in of inductor. So what is the with the voltage sources? So what will be the electromagnetic dual circuit of this? So it's very simple. So dual circuit of this, let me first, well, element of inductor is capacitor, and the connection will be the dual. So the dual of delta connection is Y connection. So uh, we will have capacitor here, let me say, and I am using this different colored marker to give you an good explanation. So this is the delta connection we are having. So for this, and what will be the circuit is delta connection of capacitors. So this is the delta connection, and the sources will be basically the same in the same connection. So this is current, and this is also current, and this is this. If I want another voltage source here, so there will be current source here. Okay, so this is the current source. Dual of delta connection is Y, so delta is dual of Y and vice versa. Say I have Y connected inductors. So this is a network, this is not a circuit. So what is the electromagnetic dual of this? So the electromagnetic dual is the delta connected capacitor circuit. So this is the full circuit. So this is the network. So this is the network of this is the network, dual network for the corresponding inductor network. So this is the Y connected inductor, and this is the delta connected capacitor. The two are dual of each other, typical dual network of the given topology. So we know that for loop the dual is node. So we have to take node. So this is a node, and this is a node, and this is a node. So for loop, for this loop and this loop, and we need an extra node for reference. So this is because, so the loops are three, but we're taking nodes, one extra node. So this is because by network, so this comes from graph theory. Okay, so we I'm gonna discuss our graph theory in my future videos if I get the time and opportunity. So graph theory for electrical networks states that for loops, I think it goes like this. So for loops are node number of nodes minus one. So that's why for nodes loop, so if I have to find no nodes for a given loop, then this will be the node number of node will be this. So uh, I think uh, that's the right relation between nodes and loops. So this is, I have to find the electrical joule of this network, and I am getting loops, so I need nodes for the corresponding loops. So the loops are 1 2 3, and I have determined nodes. So say this is node A, this is B, and this is C. Okay, so what I'm gonna do is I have to make connection between the nodes. So there is a connection from A to B. So if I take connection from A to B, the element, the branch that's cut uh, by the line is the RC branch. So I have to, so for this RC branch will be replaced by the parallel LG branch. Then B and the connection between B and G cuts the inductor, so this will be capacitor. Then then there's a relation between C and the reference node, the relation between B and the reference node, and the relation between, so the relation between A and the reference node. So A and the reference node has meaningful um, branches. So this full branch will be converted, and the connection between C and the reference node has a meaningful branch RC. So this will be converted. So when I draw the equivalent, because plus is there, so plus, then I will have the conductance with capacitance. This will go to the reference node, and this is the node A. Then I have a connection with the node B. Node B has RC, so I have parallel LG circuit. So the parallel LG circuit is, so this is the parallel LG circuit. Then I have common between B and C node. So this is node B. Then I have common between B and C, which is inductor. So dual of inductor is capacitor. Then I have So this is basically it. This is the dual network of the corresponding circuit. So hope you understood this. So this is G, this is C. So this is the branch for the series RL circuit, and there's this branch between node A and B. So, and between B and C there's capacitance. Between C and the reference node there's G and inductor, G and L. So this is basically the dual network. I don't think I have made mistakes. So that's it for this video. I'm gonna solve for many other sophisticated networks. So hope you watch those too. So thank you for this video.